Hello and welcome in this Houdini tutorial. My name is Akil and in this video I would like to share with you how to create a digital asset that takes as an input an arbitrary rectangle shaped geometry and transforms it into a subdivided quad grid. Let's dive into Houdini and get started. Here we are in Houdini. I've prepared a simple scene with a grid and the list of things to do. So procedural resample on the flat grid. After we will adapt this system to include a random position in space and rotation. So when the grid is in the space, and then we are going to create a digital asset. Okay, let's append a bound and switch it from box to rectangle and click oriented bounding rectangle. We have now one primitive and 4 points. Let's use a convert line that will measure the length of the primitives and will save in this attribute called rest length that I'll call it ratio. So if we go to the primitives attributes, we see that is 2 and 1. That is the size of the grid. Let's delete by pattern 0 and 1. And we are left with 2 primitives and 3 points. We can now, for each primitive, we can iterate from each primitive, and we can resample. But I don't want to use maximum segment length. I would like to use maximum segments. Instead of 10, I would like to query this attribute, the primitive attribute. And I can do it with using the prim function. So prim, I query the for each begin 1, primitive 0, and the attribute is ratio, and it's a float, so 0. So here now I gathered this attribute 1, this value. I would like to control that through a controller, so I create a null and call it controller, and let's hide this. Let's add an integer and let's call it number of divisions. Let's start with 1 and default 1. Apply and accept. So now let's copy this parameter and let's multiply. So if I change it here, I'll have this amount of division. So 1, 0, 1, 2, 3. So 1, 2, 3, 4. Okay. So 4 subdivisions, and of course this one will have double because it's double the length. But in this way I make sure that these are squares. Let's use a transform, and I would like these primitives in the center. So we can achieve that using negating the centroid. At this point, let's split and I would like the primitive 1 on the left. So this is short, and this is the long. Okay, and let's use a copy 2 points and copy the short to the longest. Since now we have uniform subdivisions, we can skin. And this is a result. So we created a procedural subdivided grid that for the moment works only on a flat plane. Let's create a null and call it out. So this we can collapse it and create a subnet and call it resample. So we finished part 1. Now we are going to create the second part. So this system now has to be, we have to be able to use this system also and when the grid is not flat on the origin, but also in space. So here I created a transformation with a random rotation and a translation. So now we have to move the grid to the origin and applies the resample. For that we are going to use matrices. So let's start with using a blast in primitives and 0 and delete non-selected. Okay, now we have one primitive and 4 points. Let's append the point VOP and dive inside. I would like to start from point 0, so get attribute, file first, point, position, point 0. Okay, P0, 0. Then let's take the first one, because I can take this point because we know that this is these are orthogonal and the angle is 90 degrees. So let's take the point 1 and let's subtract point 1 and point 0. Let's normalize the vector, and now let's create a null and call it y, and bind export it as vector y. I already have 3 visualizers for the 3 axes. So this is the y vector. Now we can take point number 2. So point number 2, and we just can copy this. We can use this first and 0. We normalize it. This is z, and bind it as z-axis. Okay, so we have two vectors orthogonal, and let's color it this blue and that green, and let's use a VOP called lookAt that from 0, 0 with this up and this 2 that create a matrix 3 by 3, but we need a matrix 3 by 4. And now we can use a translate. So we can translate the amount is the position 0, and then we multiply using first the rotation and after the translation, and we do a bind export, and this is a 16 float matrix called my matrix. Okay, so this is create matrix. We don't need 4 points, we can use a blast and delete point 0, non-selected. Oops. Let's now use another point VOP. And the matrix goes in the second, and let's dive inside. So we can get attribute from the second input. It's matrix 4, we call it my matrix. Okay, so now we can invert it, and we multiply the position with the inverted matrix, and that is our new position. So now this, if we activate it, this is our new position. So, and if we check it, 0 is the, so 0 is the origin. We saw that the system works if the grid is flat in the XZ plane. So we have to move this grid in that position. So let's start first to create a facet, and let's post compute the normals. Okay. So we can move it with using a point triangle, and let's call it flatten. Okay, so let's create a vector A, and is equal to our normal. Let's create another vector B, and that equal to world up vector. Now we can create a matrix 3 M, and it's dihedral, and let's A and B. We can multiply our position by the matrix, but this is not going to work yet, but this is flat now. So what we did is to move from this vector to the world up vector, but we would like also that the grid is in the center. Now it's not, because the 0, 0 is here. So let's extract Centroid that needs a name. So let's create a name. The grid. Okay, so now we have a centroid there, and let's in this wrangle. So let's get the vector first. So vector, I call it t-pos, target position, and it's a point. First input, position, and 0, because there is only one point. So before I multiply, I subtract centroid position. And this is in the center. Now I can resample it. Okay, and let's compute again the normals, because these are lost. So now we have normals. At this point, now we have to go backwards, because from here, now that we did our job here, we have to move the grid in the original position. And that can be done again with reusing this system. So let's see. We have position, we need the normal from, we need this normal, and now we have the up one, so we have to switch. This is now A, and this is B, but this will take it from the first input. And the position, we take it in the third, or in second context geometry. So now we are passing from this, and we are going to add the position, but after we multiply it. So we are here. We started here. I guess another facet. So at this point we can use Invert Transform. We can use this. Let's color it. We can use it again from the second, but we don't invert it. And here we are. Maybe this facet I put it after. So we started here with this configuration of quads, and now we are in this one, and we can go here and change it. So this is part 2 done. Let's go to the part 3 and create the digital asset. So that is pretty easy. We just take all this and we collapse it. And create digital asset. Resample. grid 2 or grid, because I already created, and accept. And then we can go in the parameters and dive inside and take this null, and we can add it here. And we can say apply and accept. And now this is controlled by this. And we save. When we are ready, we save it and we match current definition. Okay, so here I have a couple of examples where I have a grid that I created in Cinema 4D. Let's use our digital asset and let's see the result. So this is what I created now, and now this is the original. So here we have. And regarding this configuration, we can use the same digital asset, but we need to create a connectivity per primitive, and let's call it grid ID. So now we can use for each. For each primitive. Okay, we can use the grid. Name, no, it's called grid ID. And here we have the grids. We have created our digital asset that takes an arbitrary rectangle shape geometry and transforms it into a subdivided grid. If you think that something can be done in a different way or have a different approach, please let me know. So this is it. Until the next one, bye.